Welcome to another episode of Code for Thought.
Yes! Oh, c'est pas possible, ça marchait hier.
Nah, don't worry, this is not an episode in French, but we're not that far away from France. What you've been hearing is a promotional video for an online course at INRIA, one of the major research centers in France. The course is on reproducibility in research. Reproducibility of research and the reproducibility and reusability of research software is something that worries a lot of researchers and those who write code for research and science. But what to do about it? Some universities offer, or are beginning to offer, courses that teach and guide students to write sustainable software and help make your research code and research data reusable, interoperable, findable, and accessible. But very often they don't. And it's up to volunteers and organizations like, for instance, the Digital Research Academy, or courses run under the umbrella of the carpentries or code refineries and others, to fill the gap. In France, 3 researchers who all work in different areas, but are members of the main research center in the country, have come together and designed an online course open to researchers who want to learn about how to make their work reproducible. The 3 in question are Konrad Hinsen, Christophe Pouzat, and Arnaud Legrand. I had the pleasure of meeting up with them earlier in 2024. At that stage, they already had one course running for some time, but were just starting an additional course with more advanced topics. But let's hand over to them. The first to introduce himself is Arnaud Legrand.
Hello everyone, thanks for inviting us. So I'm a computer scientist actually. Usually I work on performance evaluation and optimization, mostly in the context of scientific computing. Yeah, that's about it. I'm a researcher in France.
Whereabout are you based in France?
I'm in Grenoble.
Okay, you're in Grenoble. Thank you. Christophe.
Hello, thanks for the invitation. I'm a CNRS researcher, now located in Strasbourg. I'm officially a neurophysiologist working in a maths department, and I do statistics on neurophysiological data and stochastic modeling of neural networks.
Mm-hmm. And finally, Konrad.
So again, I'm another CNRS researcher. That's what we share all together. I'm a physicist by training, and I moved rather early into biophysics. And now I'm working on computational modeling of proteins, and I've been doing this for quite a while. And in that respect, this function, at some point, I stumbled over reproducibility issues and then more reproducibility issues. And nowadays, I would say half of my work is reproducibility issues, and the other half is biomolecular modeling.
And a tiny little bit of that is also teaching, because what we're talking about today are MOOCs. So I try to disentangle the acronym that means mass online courses.
Massively open online course, I think.
Massively open online course. Thank you very much. Yeah, and I think one of the first, or maybe not one of the first ones, but certainly one of the well-known ones was Coursera, which was set up in the US by Andrew and G, I believe. But you've been doing your own for quite some time, and I think that's the one we want to talk about today. And in fact, there are 2. There's one longer running, and then there is another one which just started. Maybe we can start with an introduction for the one that's been running for a while.
We are helped by a specific lab at the INRIA to prepare the course. It's not only the 3 of us who worked on it. So we worked on the content, but all the logistic that goes around, which is not negligible at all, was taken care of by the learning lab at the INRIA. And that's very important, because without them, that wouldn't have happened. I think that Arnaud, who got in touch with the people, or the people from the learning lab at the INRIA got in touch with him, and he knew both Konrad and myself, and he proposed us a few years ago to engage into preparing such a MOOC. I guess we are naive enough to say, well, go for it, that's great. Because we thought that wouldn't be so much work. It's actually a lot of work when preparing the lectures, recording them, and things like that. But that's a great occasion to learn. And so we focused the first MOOC on basic tools that can appeal to essentially anyone involved with numerical documents. Our view, of course, is people doing some quantitative analysis with computers, but a lot of the tools we present are also relevant for people just having to write on a computer on a regular basis, having to archive their work, follow the different versions, and collaborate with other people. So we try to cut the different parts of the first MOOC so that even people from human sciences could profit from it, even if they don't have to do some quantitative work also.
I think we're getting maybe a little bit ahead now. I wanted to ask, what was actually the motivation to set up a MOOC? Right, because you're working in French research centers, CNRS and INRIA, I think, are research centers in France, as I understand.
Yes.
So there is teaching going on anyway, I would think. But what was the motivation behind creating an online course, a massively open online course?
So in my case, I guess my concern dates back from like 99 when I was doing my master internship, and my interest continued to grow during my PhD. Because in my community, there was a very poor culture of experiments. So many studies were actually conducted with simulators, and every new PhD student was redeveloping from scratch its own ad hoc simulation tool, which had many shortcomings, in particular regarding the realism of the outcome. And it was almost never discussed in the paper. So I was kind of worried about this. And furthermore, the code was almost never made available. So I quickly realized I could hardly trust the result. So that was my first concern with the reproducibility issue. It was more of a cultural problem in my community. So my own practice were not significantly better. So I first decided I should level up. And then once I would have leveled up sufficiently, then it would be the right moment maybe to share what I had learned with others. I guess Konrad and Christophe had a similar experience, probably with a few differences. But my motivation was really to share with as much person as possible good practices that I had learned.
Yeah, maybe can add my story a bit about this. I have had personal problems with reproducibility in my field for a long time. It started back in 1995 when I was a postdoc at the University of Montreal, and I had a compiled piece of program that was supposed to do some nice work for me in quantum chemistry. And I ran it overnight on the two computers that we had in the lab that were supposedly identical, and I got different numbers. And I did it by 5%, and the technique was supposed to be accurate to better than 1%. So that this just couldn't be right. And actually, I never figured it out, and I gave up. I switched to a different software in the end. So that was my memory back then. And I regularly encountered similar problems later on, and I found my colleagues as well, and nobody knew what to do about it. And it was kind of a mystery to people in our field. And then as I figured out where the problems came from, I said, well, I need to share that with others, because it's not just my colleagues in my office who need to know, but people, I don't know. And it doesn't take long to find that there's no courses at the university level. So you can't just sign up at your local university for a course in dealing with research problem and software and its problems. So when Arnaud proposed to do a MOOC, I said, that's the occasion to find the right framework where you can do something immediately without waiting for universities to catch up and take up a new subject. That will take 20 years. So I'm not saying a MOOC is the perfect way to do this, but it's better than nothing, and there's nothing else. The occasion to improve the computational practices in computational science.
Christophe, what was your route to MOOC?
By training, I'm an experimentalist in neurophysiology, and for almost 20 years I did mainly experiments. So that's a field, I mean, almost any experimental field has a rather strong tradition of documenting the way experiments are carried out, how the data are analyzed. But still, when you read papers from colleagues working more or less on the same brain region, in that case I was working on, you always have, the noise level is not the same as in your experiment, or there are details where, you would like to have more precise the idea of where the difference comes from. So I was kind of frustrated for a long time, not always being able to understand what was the origin of these tiny or sometimes big differences. So of course you have meetings where you can meet colleagues, talk directly to them, but still it's bothering to have to talk to people in person. The science should be accessible to anyone. If you have to travel around half of the world to meet someone, it's a bit bothering. And when it comes to the more quantitative part of experimental work, so when you do heavy data analysis, then the standards of documenting what you do are much lower. And so this frustration I felt from the data themselves was even stronger when I was dealing with the data analysis part. After 10 years in experimental work, I started using the software R for statistics. And R, at that time, had already a very nice feature that was the sweep function that allowed you to mix prose with code. I'm far from being a good enough programmer to develop this kind of tool myself, but that was what I was looking for at data analysis level. So I started using it, and I tried to convince my colleagues to use it without much success, I must say. I mean, they looked at me as someone from Mars. So I used it for my own research and trying to do some advertising for it. And at a point, Konrad invited me to a one-day meeting about reproducible research. I realized that other people, at least in France, had the same concern. And so we started talking about this subject. And the problem we had is that, I mean, in a single university, it's still too much of a niche subject to develop a full course where you would have 20, 30 students. So it made sense to start with at least. We proposed a course that would be available online. So we would touch enough students because, again, that's a lot of work to prepare this kind of course. And it's better to have an audience when you embark in such a large task, so to speak.
I think the beginnings of it would interest me because you mentioned that you thought it would be a lot easier to actually start something like this. But what did you actually find when you started that? Where were the stumbling blocks and the difficulties?
Fortunately, we were guided, as Christophe already mentioned, by professional MOOC people at Vielen Dank because it's a very different thing. So yeah, you have to present, for example, we do video lectures. And of course, people have some experience about what is a good length for a video lecture. So it's something like not more than 10 minutes, for example. So you have to cut things down into pieces of between 5 and 10 minutes. Mm-hmm. You have to complement that with exercises, and the exercises must be graded automatically by the computer for the majority, because otherwise nobody's going to write 20,000 exercise answers. So that you have to adapt to the medium. That's one thing, and fortunately we had people to help us with that. And then it's simply a lot of work. It's not necessarily difficult, but it's a lot of work. Yeah, I would say it's more the amount of fine-tuning that you do, because you do the whole course up front, and then you press a button and open it. It's not like in a real life course where you sense your audience, you see the kind of feedback and you adapt your material. You can't do that. It has to be comprehensible to something like 90% of the people who are, you never get 100, right? But it has to be good for at least 90% of the people who are following, and you get no chance to adapt to them. It's a one-way communication. It's quite different from teaching directly.
I would imagine. Maybe we can look a little bit at the curriculum, what actually was covered. So you mentioned reproducibility. There are several elements to how you can improve on reproducibility of research software. So what's covered by the course?
There are two MOOCs. The first one, I'm going to start with the first one.
The long-running one.
The long-running one, exactly. The first edition of this one dates back from 2018. The edition which is running right now is the third one. In terms of organization, there are 4 modules, and the approximate amount of work for each module, a week of work. And so the first module is about laboratory notebooks, I would say, how to take notes on what you're doing, how to make sure that it's going to work for you and for others to read, how do you organize your information, this kind of thing. So we promote open source tools for that, or formats. In particular, we explain people how to use platforms like GitLab, and we drive them to formats like Markdown, for example, for simple note-taking. The second module is aiming at presenting what we call computational documents. So Christophe already mentioned that means the ability to have in a single document both explanation, code, and the output of your code. Because it's very common when, for example, when you analyze data, that what you're going to do depends on what you see somehow. So meaning the ideal organization should be something like, here's what I want to do. So you just explain it for yourself, for someone else to read. Then you write your code to actually do the work. Then you get the result, and based on this result, you say, okay, now from what I see, the next things to do is this, and you proceed like that until the end. Okay, so the goal is really to explain to people what you're doing, much more than just write code, obviously. So we present 3 different tools in this module, which are Jupyter, which is pretty famous now, RStudio, and Org Mode, which is based on Emacs, which we happen to use. The 3 of us actually use this tool on a daily basis.
Yeah, well, I do remember Emacs, so from my own uni days. So sorry, I'm getting flashbacks now.
Well, it still works pretty well, actually, more than ever.
Indeed.
But actually a fun story behind it, because initially we said, okay, we'll do Jupyter notebooks with Python and we'll do RStudio, so we'll use R. And at some point we said, well, actually, neither of us actually uses neither Jupyter nor R. We all three of us use Emacs. So why don't we teach people what we actually use ourselves? It is a bit exotic. Emacs is not not so much mainstream, but now we have people who sign up for the book exclusively or mainly because it's the only occasion to learn how to do computational documents in Emacs.
Right, okay. Yeah, I'm quite surprised myself, to be honest, because there's a plethora of different integrated development environments out there nowadays where you can do that stuff. And of course, there's Jupyter itself, which is not only for Python, it's I think also for Julia and R.
But indeed, those are computational notebooks, which is not exactly the same as an IDE. What I mean by that is I would never develop code in Jupyter. I mean, that's really not designed for that. It's okay for writing computational documents. It's very easy to set up. Actually, when Konrad said we did not use Jupyter on our studio, actually, we do, but mostly for teaching, because it's generally easy for students to use. But indeed, for our daily practice, it's not the most convenient tool. There's several shortcomings. RStudio is actually an IDE, not the most powerful one compared to others. And Emacs is like a general purpose editor. So,
indeed. Well, I think we got a bit carried away with tools. I guess this is what happens when you have a bunch of engineers in the room. But let's go back to the curriculum of the first MOOC Konrad, Christophe and Arnaud created. After all, we've only covered 2 of the 4 modules.
The third module is on how to write a replicable analysis. So we show students, actually Konrad explains students how to restart from the data and apply everything step by step without doing any manual intervention. The idea is really to make everything completely explicit to avoid anything manual. And this module is interesting because there is an evaluation in the end where we do what we call a peer evaluation, meaning we propose every student to choose one subject among, I think, 7 different ones. So where for each subject, there would be one on carbon concentration in the atmosphere, one on the cholera epidemic in London, so very different topics. They're given data and a few questions to answer, and their mission is to write a computational document to answer those questions. And mention the peer evaluation because then once they submit their documents, their work is going to be reviewed by other students who follow the MOOC. So every student submits his work and every student will receive the work of 2 other students to review. And so what we ask them to do during the review is to evaluate whether they could understand what's in the document, whether they could reproduce some of the thing, whether they could follow those kind of things. And the last module is a bit more depressing because it's mostly about explaining our students why this is only the beginning of a very long and painful road, meaning there are so many other pitfalls that they could stumble upon. And that was actually our introduction to the second MOOC, but maybe we will talk about the second MOOC later.
So there is obviously a lot of logistics involved in setting up a MOOC of that order. So there's the preparation of the classes itself, the material, which includes video presentations, I understand. Then you have to have a way for students to sign up. There is a way of making the class notes available, which I think is probably through the digital documents, which is something students probably learn during the MOOC, I'm guessing. And there's also what you might call the homework, the MOOC homework, and then the review of all of that. So how did you go about it? It seems like quite a formidable task. And how long did it take you to get this up and running?
There are platforms for that. You already mentioned Coursera earlier on, and we are using a different one, but it's the same style. It's called FUN, France Université Numérique. So that's a whole website which is made for MOOCs. It has a certain structure. So your MOOC is structured in modules, and each module has units. So we basically prepare our material to fit into this general framework. So we designed everything right from the start to fit in that framework. And then again, we had the MOOC experts at the INRIA Learning Lab who know this platform very well and who told us how to prepare the material for it. The video lectures are an important part of it. So they were actually done in a professional studio with professionals who recorded us and made subtitles and all this kind of stuff. So this is very nice that we didn't have to worry about this. So we did not present our exercises on in computational documents because we used the Fun platform, because this is for MOOCs in general. It's not just for ours. There's then for each exercise, there's a kind of a small web page, and there are different levels of exercises. There are quizzes where you basically have a question and there's 3 answers, and you click one of them. And we can check if the students correctly understood and memorized the material from the lectures. And then there are more exhaustive exercises where they actually do something, they have to compute something and give an answer, which they type into a field in the website, and they click a button, and then the computer checks if it's correct. So there's a whole infrastructure behind it. It was already there. It was not our business.
You 3 got the idea of doing something like this, but you probably need to convince people at INRIA or someone to help you with that and help you set it up.
That kind of worked the other way around. I guess I've been pretty lucky. So INRIA, like CNRS, are research centers. So they are not per se involved in teaching. They do a bit, but it's not comparable with a university. That's the first point. Yet in research institutes, many people do teach. I do teach at university, Konrad as well, Christophe as well, etc. And so there are people indeed in particular at INRIA, whose role was to make MOOC, because diffusion towards society is one of the mission of those research institutes. And so this reproducibility issue was a topic that Jean-Marc Hazenfratz, so who was at the head of the Learning Lab, had heard about. So we knew each other's. And so one day we just crossed and said, okay, we need to talk because I'm the head of the Learning Lab, so that's what I'm doing. I think that the topic on which you're working, I see you're doing a lot of seminars, giving a lot of talks on all that. Maybe there's something to do. Okay, and so that's actually how it started. Christophe said earlier that he was naive, that he didn't realize the amount of work it would be. On my part, I guess I was even more naive because I said, okay, great, maybe if I do this MOOC, then I won't have to do seminars anymore on that. And actually, that was obviously completely the opposite. I only have to do much, much more seminars on this topic. For the date and the time it takes, because we took notes, we take a lot of notes, so I have my journal. It was easy to check. And so I guess one of our first meetings was in March 2017 with Christophe and Konrad. And the opening of the MOOC, of the first MOOC, the first edition, was October 2018. So it gives you an idea of how much time it took before our first meeting was, okay, we're going to do something, and when things actually start. This being said, for the first MOOC, it was actually much easier than for the second one.
Oh, really? Because that was my question, actually, because you just started the second one. And why was that more difficult than the first one?
For me, it's because the first MOOC covered tools that we are using in the 3 of us every day. So we are just explaining how we do our daily work. And as Arnaud mentioned, the 4th module of the first MOOC is just a brief overview of what we didn't talk about in the first MOOC, so the nasty details. And the second MOOC is about these nasty details. So we all solve them on a actual basis every day, but when you have to put everything together and explain, you always have a specific solution to a general problem. So we try to present the general problem and then come to the specific solution so that people don't depend on the solution we propose. They have a global understanding of what they are facing and what are the possibilities. But still, it required much more work to get to know precisely what are the tools available now, what are the ones that are reasonably reliable. That's also a very dynamical field. So people propose solutions on a weekly basis, so to speak. And we want to have tools that will still be there in 10 years or 20 years from now to keep reproducibility meaningful. And it's hard to know among all the very nice solutions that are proposed now, which ones are likely to survive and which ones are not. And we are not sure that we get the right choices, of course, but that's why we also chose to present the general ideas and not only the tools.
Well, I would say another important point is that the topics of the second MOOC are much more technical. And that's also why we asked 3 research software engineers to join us to help us with these things, because we knew that this is a good tool for doing this stuff, but we didn't necessarily know all the details of how to use it best. So we wanted to have people with us who actually do this in their everyday life. So in the first MOOC, we had the typical exercise was write a computation document that explains a certain data set. That would be printed out. That would be maybe like 3 pages, and the whole code runs in a minute. Mm-hmm. And in the second MOOC, our running example is an analysis of a database of 50,000 images taken from the sun, where we do some sunspot detection. And then we do time series and averages and all kinds of things on that. So it's much larger data sets. So we have to do data management on a completely different scale. In the first MOOC, the data was a single CSV file. It's also the scale that makes the difference between the two. I certainly had done analysis on this scale, but not every day. I do this every couple of years. And my experience from 5 years ago wasn't worth much anymore, for example. A bit as Christophe said, it is a different level of technicality, a different scale, and a different rhythm of evolution of tools that we had to deal with.
What's the curriculum for the second module? So what's the content?
It's 3 modules for now. We want to add a 4th one later on, but we started with the first 3. The first module is about data. It's how to organize the data in the project, how to pick decent file formats to store data in that are likely to survive for a couple of years, ideally decades, how to archive data in the end. So that's a big chunk. The second module is about computation environments. I think that's the longest one, by far the longest one even, because computation documents that are reproducible are actually still quite tricky to do. And there are many false solutions. You have to argue or convince people that what everybody tells them to use is actually not a solution. And that takes more effort. It takes more effort to debunk false statements that are popular than actually to tell somebody how it works. So in the end, it's almost a course on how operating systems work. Arnaud has been doing that. Has been doing that very well. But I kind of regret that we had to go as far as to tell all these details. It shouldn't matter, but unfortunately it does. It's also long because we start with the, say, well-established tools, in particular based on Debian Linux. And then we move on to the kind of what we expect to happen in the future, and we use the geek system. And so we have kind of 2 different approaches, which we explain in very much technical detail. The third module is on workflows. And there the major issue is there's hundreds of workflow managers, and each scientific discipline has its preferred workflow manager. Whatever we pick is going to be of no interest to 90% of our audience. And so our real mission is to teach people why we need workflows, what a workflow is, how it works, roughly in general, without going into specifics. On the other hand, if you want to do exercises, we have to use specific ones. So and after long discussion, we decided to start with Make, the good old Make utility from compiling software, for historical reasons, but also because that you never regret learning Make, because even if it's not what you use for a scientific workflow, everybody has to use Make sooner or later if it's only for compiling software. And then in contrast, we use SnakeMake to show something which has the same basic idea, but does things differently. And then we go into details. What are the differences? What are the advantages and disadvantages of these tools? And then to point out what the space of workflow tools contains and what you have to watch out for.
You mentioned GUIs, which I think may not be that well known outside France. Could you quickly say what GUIs is?
Well, it's not specifically French. It has been started in France, but the community is scattered around the world by now. So I wouldn't say it's French. Geeks is one of a new kind of software managers. The other one is Nix. There's only 2 of them, which Nix goes back to a PhD thesis by Eelco Dijkstra from 2006. So that's not very old stuff. And the idea is to think about computational environments from the start. If we can get rid of the baggage of the past that makes life difficult, is it possible to make a computational environment completely reproducible from source code? The thesis that describes Nix says what you have to watch out for and proposes one way to do it. So Geeks is the second implementation of the same idea. At fundamental level, the 2 are the same. But then there's lots of technical details that differ. And personally, I think that Geeks does a better job to have tools that are good for computational science.
So let's talk about your experiences, not with the second one because you just started, but what were the key lessons that you learned now looking back 6 years of running the first MOOC? What were the kind of the 3 things that you thought, oh, well, if I had known that in advance, then I would have done it differently?
Some of the tools we exposed in the second MOOC, in fact, would have been useful in the first because, as you said, the first MOOC has been running for a long time now, and because the students can use R with RStudio or Python with Jupyter Notebook, and great effect of being supported by the learning lab of the INRIA was they gave access to a Jupyter server and a Git server to the students. But when you make an update of that, so new Jupyter comes out, the new Python version comes out, and there's a tiny thing that is changing in the output of your code. And that's a bit painful. That's the kind of scary stories you get when you have a MOOC on reproducible research running for a long time.
Yes. I tried to go back to, I think it was Konrad who said that video lessons were 10 minutes long. Is that something that you realized straight away, or was there a learning process when you said, okay, this is the right length for a lesson?
We said we're working with MOOC professionals, and they knew these things. They told us, and we didn't think about it. So it wasn't our business, basically.
We didn't have a choice.
Okay, so they basically told you, okay, it's 10 minutes. Yeah. But were there other lessons that you learned that you thought, if I had known this at the beginning?
Something that's particularly painful when designing such a MOOC or when implementing such a MOOC is that the platform that we are using, like Fun, but it could be the same with Coursera and everything, is one of those web content management systems. Like, so you have to do everything like through the interface. You have to click and write text, and it's incredibly painful. And that quickly drove the three of us completely crazy. So we say, oh, wait, this is never going to happen. We're never going to be able to design materials and resources for the students through this kind of interface. So instead we said, okay, we're going to use the tool that we promote in our MOOC, meaning the first thing we did was to set a Git project to write every content with org mode or with Markdown, okay, in file, and to set up some scripts that push automatically the content of what we write in Fun. So this way we didn't have to go and click and edit all the time. We could work with our tools in a natural way as we would write an article or a book, and everything would go on the website like almost automatically. And our colleagues from the Learning Lab were quite happy about this and used this technique then for all their later MOOC, because that was streamlining the whole process so much. That was really helpful. For the exercises, it's harder. Okay, we can do that for the lecture, or for the explanation, for the documents, for the resources, rated work, this kind of thing. Mm-hmm. But for the exercises like the peer evaluation I mentioned earlier, it's not the kind of thing you want to automate. It's not worth the effort. Mm-hmm. We try to set up some reproducible workflow for the MOOC, and that was helpful.
I would like to move on to a slightly different question. So looking from the student's side. So we're coming to the end of the recording now. As a student, if I sign up for one of these courses, I probably get some kind of certificate or confirmation that I've done it and that I've passed it. How is that going to help me in my study? So the hope is that it will help them in their research, in their career as a researcher, or as a software engineer in general. But in their career, they probably need to demonstrate that they've done this and this and this, and it's usually done via certificates. How do these certificates or these confirmations that they've taken part help them in their studies? Does it help them?
In terms of certificates, actually, things have evolved a bit through time. What I mean by that is that the way the Fun platform was delivering the certificates has changed. So now they're releasing what they call open badges. So which is kind of a digital document that says that, yes, this person has been followed this lecture and this is what it means. Then how those certificates are recognized by universities, etc., then it's another debate. So what we do in France is every PhD student is enrolled in a doctoral school and has to follow some lectures, to receive some training during the PhD. And it's possible to follow a MOOC, for example, and to have this be accounted for some of the training you followed. So we did contact all the doctoral school in France to tell them about it, to explain them what the topic was about, how much work it represents, how much work we would consider that it should count for the PhD students, and that had them advertising this MOOC to their own students. For some doctoral school, it was not relevant, but many of them actually used it and proposed it in their catalog of possible lectures.
Okay, well, that's encouraging. The final question that I have is what the plans are. I mean, part of the plan is to run out the second MOOC successfully. It's just started. So beyond that, how do you see the future of this?
We are probably busy for quite a while with the second MOOC because we are running the first session, and our experience from the first MOOC shows that The second session is going to be different. So we will learn from the feedback from the first session. We'll improve the MOOC for the second session. Our great ambition is to add a famous module 4 that we've been talking about for quite a while, but never got around to do. And while we might actually end up doing it. So even polishing and continuing to work on the current MOOC is probably all that we are going to do at MOOCs for at least another 2 years. I personally have no intentions beyond that for the moment. And I think Arnaud and Christophe are not terribly enthusiastic about a third MOOC at the time either, but I'll let them speak for themselves.
That would be total madness, I think, at that point. We're going to already stick with what we have.
Do you think about passing on the baton, so to speak, to someone else to continue the work because you think, I had enough of MOOCs now and I want to do something else? Do you think there is kind of a succession?
That's a good question. I don't know if people will do other MOOCs, but I mean, a MOOC is one of the many different ways of improving practices, of promoting things. The way you learn when you're in a summer school, for example, or when you meet with people in a room for real and exchange, it's also completely different. So what I see here is that we designed the MOOC so that every part could be stolen and reused by anyone. Every of our material is released under a Creative Commons license. And all the text, it's not locked in the Fun platform. All the material is available on a public website next to it. So what we hope is that people will reuse the part that they need and adapt it to the audio that they have. And maybe then there will be a contribution from people that will realize that I think this part here is really important and should have been there. That's actually what happened for the first book. Between the first edition and the third edition, a lot of additions from colleagues. Right. And so it's hard to tell now what's going to happen, but we expect the same will happen with this one.
Okay. Well, thank you very much for your time today. I think your time is very precious and very valuable, so I don't want to take more of it. It sounds like a great thing that you're doing there. So all the best for the future. And thanks very much for your time again.
Thanks to you.
Well, thank you for the occasion for presenting our work in this podcast.
If you live in France and it's the first time you hear about this, check out their website where you can register for a course. Well, this is the end of 2024, but there's one more episode to go. Because 2024 was the year when we lost a number of pioneers in computing. Niklaus Wirth was one of them, and I hope you enjoyed the episode I published at the start of December 2024, which focused on one of Niklaus Wirth's creation, the Pascal programming language, and its influence. But there were more. In November, Thomas Kurz passed away on the 12th of November. He's known for having co-developed the programming language called BASIC. And earlier this year, we also lost David L. Mills, who created the network time protocol, NTP, a tool that makes sure our computers remain and are in sync. And this will indeed be the subject of the very last episode for this year, 2024. And as per usual, it'll be great to leave a review on your podcast app or give me some feedback via my LinkedIn, Slack, Matrix, Blue Sky or Mastodon profiles. And don't be shy to contact me via email or text. All details can be found in the show notes. Oh, time's up. See you next time. But before I forget, this podcast is covered by the Creative Commons license. See ya.